Okay, so we have a 2013 Mazda CX-5 here, and the concern is that the air conditioning isn't working. So, things that I've already checked on it. I got my UV glasses, or my UV light and my yellow glasses out, checked for leaks, didn't find anything. I don't have a set of gauges to check air conditioning pressures, so I have to just sort of I gotta check all my bases before I can really check that, because I don't have gauges. So I plugged the scan tool in to see if I could get some data from the pressure sensors in the lines to see just how much refrigerants may be in the system. But for some strange reason, I have no communication with my AC module, which is actually integrated into all the dials in the vehicle. Now, those HVAC controls do function. I can turn the fan off and turn the temperature up and down. I can hit the AC button and the light comes on. So I'm suspect of my scan tool actually not talking to the module for some reason. I think it's just something to do with my scan tool, maybe not liking that. It is a snap-on scan tool, but you know, these things happen. So the next thing that I'm going to try to do is check the clutch, the magnetic coil that's in the compressor that engages the clutch. So that's usually another thing that goes bad. Sometimes those coils go open inside, where a wire will break in the strand or it'll short together. So just gonna take my meter and we'll check it out. So based on the wiring diagram, there's a main power fuse. It's a 7.5 amp fuse, and it is located right here. So just gonna check to see if it has power first, and that fuse then feeds voltage into a relay that actually controls the clutch. So we'll put this hooked on here. There, so you guys can see. Make sure we actually have good ground. Looks good. So 12.11 is what our battery is. Yep, 1211. Both sides of the fuse. Perfect. So now we should technically have power into our AC relay that's controlled by the HVAC module. So this is the relay here. So just looking at the bottom of the relay, you can see that these terminals are much heavier, which means these actually control the current that goes to the AC clutch coil, and these ones are the control side of the relay. So we should have power going to one side. According to the diagram, it's hot at all times. So we can see we got nothing there. And we have battery voltage on that side. So we know power is coming into that side of the relay, and it's waiting to be commanded on, and the switch closes to feed power to the other side and go down to the clutch. So what I'm going to do is use my power probe and try to feed power down that into the clutch and see if we can hear it click on and off. Probe here. You could also just do this with a jumper wire, really, and just jump it across those terminals, right? But I like using the power probe, so we're just going to try that. Okay, so this should be able to, yeah, you can hear that if you want to go over there. Okay, so we know that the electric coil inside of there is creating a magnetic field and pulling the clutch, engaging the clutch. So we know that that's working, but maybe there's something wrong on the control side. So what we're gonna do is we'll rig up a test light, I'm thinking, and then we can turn the air conditioning on and see if we are actually getting a signal from the HVAC module inside. So we're just jumping a test light across the control side of the relay, basically where the coil would be. When the HVAC module sends power to the coil to energize, create a magnetic field, and pull the switch closed on the relay, we've just put a test light in there instead. So as you can see, test light's not lighting. We have no signal. Now chances are it's probably because the refrigerant level's low, but like I said, I don't have gauges, so obviously if I had gauges, that would probably be the first thing I would do, is put a gauge set on, see what our refrigerant levels are, but that's fine. We might try to put an oscilloscope on the pressure sensor and see if we can get a reading that way. Close to 5 volts. Yep, that's my 5 volt reference, and this will be my ground. Yeah, that'll be my ground. Yeah, so we've got, let's see, we got blue wire with a black tracer. Oh, they both look like they have blue and black. They do, they're both blue and black tracer wires. That's silly. So the one that's closest to the engine, blue wire, black tracer, that's our ground. The center wire, which is also a blue with a black tracer, is our signal wire. And I'll just back probe this so you can see on the multimeter what reading we've got there.
0.11.
Yeah. And then this gray wire, sneak down in there, that's our 5 volt reference. So I'm guessing, I don't know, here's the next thing is, I don't know what signal we should see for like what determines high and low. Like is close to 0 low pressure up to 5, or close to 5 high pressure. That's what I'm assuming. So in this case, I'm assuming that, you know, we have low pressure. And this sensor is on the high pressure line, so I would expect it to be somewhat high pressure. The lines do equalize after it sits, but yeah, I don't know. I'll have to check and see. I have another car that I could pull in and check as just like a reference, but I don't even know if the air conditioning works in that thing either, so. Does that like light up at all?
A bit, yeah. Here we got the glasses. What's that look like to you?
Yeah, that's definitely dye that's in there.
Yeah.
I just wondered if it was any different from what you can see with or without the.
Yeah, it looks.
But anyhow, so the only thing that I could really find was, I think either the Schrader valve that's in here has been leaking, or somebody's pumped it up with dye in the past. One or the other. I know when I worked at Toyota, it wasn't uncommon to see these Schrader valves start to fail, and they would be a slow leak. Now there is a seal on the inside of the cap, so it's not something that would leak super quick. I was really expecting to find a leak somewhere, but I've double checked everything. We checked the drain for the HVAC box, and that would check the evaporator core that's located inside the HVAC box. If it was leaking, dye would leak into that HVAC box that's in behind the dash, and then water drips through a drain that comes out the bottom of the car, and that's where the dye would come out to let you know that evaporator core is leaking. So it was clean, and yeah, I've double checked everything, checked the condenser. A lot of times, you know, take a stone in the condenser and it'll cause a puncture, thing will leak, but I can't really find anything. I've checked the lines that go into the firewall and the thermostatic expansion valve, and those look okay. It's sort of deceiving too if you ever use these UV lights for the first time. Undercoating and corrosion on aluminum will also light up fairly bright. But you'll know the difference if you see dye. It is really fluorescent, it really lights up. So just watch if you do ever use this for the first time. Be like, holy, there's a leak on these lines, but it could just be corrosion. But I would say the next step, based on not having gauges or a machine, would be getting some gauges on it, see how much refrigerant's in there, evacuate the system. and pull a vacuum, do a vacuum leak test on the system, see if it's leaking. If it passes a test, I would put new Schrader valves in it and charge it up. And then, yeah, check the system. If we do put gauges on it and the system's full, then I would go back to why the computer isn't sending a signal to turn that relay on to power up the clutch. As far as I could just find online with the pressure sensor on the high side there, it seems like the lower voltages, like somewhere around a volt or 0.8 of a volt, is low pressure signal, and then upwards of 5 volts is high pressure. So the computer pretty much disables the compressor once it gets to about a volt or lower, and it also disables the compressor if it goes above 4.7, 4.8 volts, because the pressures are too high. And that may vary depending on the vehicle and the manufacturer. Those are just rough ballpark numbers that I found. So my suspicion is that the system's too low, and the computer knows that. It's getting a reading from that pressure sensor, and it's not turning the compressor on. So yeah, gonna have to probably send this one over to a shop that's got a machine, unfortunately, until I get a machine here, which is soon. But yeah, maybe do an update video, let you know what we find.